All right, here's the video for 9.7, lengths of arcs. Okay, we're going to be able to find the circumference and the length of a circular arc. We're going to talk about what those are, how they work. We're going to use the circumference and find arc lengths and solve real-life problems. That's our goal for today. So on your cheat sheet, you'll see up here, we have the equation for finding the circumference of a circle. We're going to use that to find out what the length of a circle is, okay? So the circumference is the distance around the outside of a circle. If our diameter is across the middle, then our circumference is all the way around the outside. Around the outside. Around the outside. All right, so my circumference formula is circumference equals pi times d, or circumference equals 2 pi r, because we know that d is really just twice as big as the radius. Now, if we solve this formula for pi, then we're going to end up dividing, not on my marker, dividing both sides by d. Not the d. There you go. And then we're going to end up with pi. Why is it typing? All right, we're going to end up with pi d. So when I do this, I recognize that pi is just a relationship between the circumference and the diameter of any circle. So it doesn't matter how big or small the circle is, if I take the circumference and divide it by its diameter, it will get me pi. That's why it's got its own special name. So if we look at this as a circle with a radius of 1, we can see how many times is the circle. There's pi, and there's 2 pi. So the circumference, the distance around, was 2 pi when the radius is 1. If the radius is bigger, then it becomes more than just 2 pi. So 2 full rotations, 2 half rotations, got us to 2 pi. There's half rotation was at pi, full rotation was at 2 pi. All right, now if we look at with a diameter of 1, now it's 1 all the way across. See that? 1 all the way across? Then there's half pi, there's full pi. Okay, so the diameter was 1, and therefore the circumference was just pi. Our equation was circumference equals pi times d. So if its diameter is 1, then it's pi. The circumference is pi. Hopefully that visual helped some of you. So if we're finding the circumference of a circle with a radius of 8√3 feet, then I just have to remember I got my equation for circumference, I substituted my answer, and then I do multiplication. 2 times 8 is 16. I just leave it as 16 pi root 3 feet. Notice it's not feet squared. That only works with area. If we're talking circumference, then it's a linear distance. So we leave it as feet. Okay, in this example here, now we're looking for the area. Well, we have the formula for the area is pi r squared. We substitute it in as 8√3, and now we square each one of those. So 8 squared is 64. Okay, if we reorganize the expression, help us see it as 8 times 8, which is just 8 squared, and root 3 times root 3, which is root 3 squared, and then feet times feet, which is feet squared. So now we just square each one, 64, 3 feet squared. And we end up with pi times 64 times 3, which is 192 feet. 192 pi feet squared. Again, don't try and multiply this by 3.14. Just leave my pi alone. It's my pi. Okay, feel free to pause the video, watch or work on problems 1 through 8 of your homework. To give you an idea of what this is talking about on the homework, we have 6 feet. And then I take 2 pi r, so 2 times the radius is 12. So it should be 12 pi feet. The area, now we're squaring the radius, so it's going to be 36 pi feet squared. Now here, if this is my circumference, 8 pi, then my original radius should be half as big as that. So it should be 4, because 4 times 2 is 8. Okay, so now if my radius is 4 meters, then my area should be 16 pi meters squared. Now, if this right here is my area, then I have to square root this to find my radius. So the square root of 100 is 10, and there's no pi there, it's just 10 feet. When I plug this into my radius formula, I get 20 pi feet. So it's kind of an example on how to do some of the problems in the homework. Okay. You can ask questions from the internet. So length of a semicircle is 1/2 of the circumference. So if the circumference is 2 pi, then the length of a semicircle is 1 pi. And the quarter or 90-degree arc is 1/4 of that amount. So it would be 1/2 pi. So our formula for how to find the length of an arc, okay, we're looking for the length of arc AB, is right here. It's on your cheat sheet, okay? But if I want to know how long the arc is of AB, I have to find the arc length, the measure of the arc, right? AB, the measure of the arc, and then divide that by 360 to find out what portion of the circle it is, and then multiply that by the entire circumference. Okay, notice 2 pi r, that's the equation for circumference. We're going to get to see a lot of how this works. That's part of the essential question here. What proportion is used to find the arc length of a given arc? The proportion is the arc length of AB with relationship to the full circumference should be equal to the measure of the arc in degrees compared to the full circle measured in degrees. So then here we cross multiply and we solve some different things. Let me clarify, this is what you should have an answer for your question. Before we move away from this concept real fast, I want to show you kind of how this works, all right? If I have here the measure of angle AOB, okay, sector AOB is described by this with the radius centered at O. Notice this centered at O part, that's important, okay? That means that this is a central angle. That means our arc length is equal to this. So I take 120 and I put it over 360. That reduces down, the zeros go away. And 12 over 36, that's the same thing as saying 1/3. Now, if I'm looking for the circumference, I can plug in r into my circumference and get 12 pi meters. And now I take these two numbers and multiply them together, and I get 1/3 times 12 pi meters. And this 1/3 times 12, that should reduce. What's 1/3 of 12? Well, 12 times 1 is 12, divided by 3 is 4. So my answer should be 4. That's the length of arc AB. Notice how it's not the measure. We're not talking about degrees anymore. That was up here. Now our new concept is finding out exactly how long it is. Okay, so there is a little brief intro and a visual for how that works. Let's go back to this example is extra credit. So we're going to skip it in class, but for you, we're going to work through this one together right now. All right, so I have here the area statement. Again, in your notebooks, you'd see what this looks like. As a matter of fact, let's do that in your notebook. Why not just do that? If I find 9.7 in your notebook, where is it? Almost there. Okay, it says here, find the circumference of a circle with the area is 100 pi meters squared. So my area formula, this is the formula. Okay, this is my equation. Sent the wrong email, the wrong person. 100 pi meters squared. So I set this up. This is my substitution. Now I'm going to solve for my radius. So I divide pi to both sides. So what does this look like? Usually we say division property of equality, because I can divide both sides by pi. And then that gets me to here, 100 pi meters squared equals r squared, okay? And then from here, I have to get rid of the square root, right? So I square root, what's this, the square root property? Let's just do square root symbol. Square root, oh my goodness. Okay, square root property of equality. I can square root both sides. From here, it looks like we just simplified the fraction. Simplify. Again, you have to listen to watch while I'm writing, because you may not be able to read this. The marker thing on the computer's, finicky. So right here, we simplify again. Okay, so I square rooted both sides, and now I find out that my radius is 10 meters. So now I'm going to substitute. Here's my equation. Let's see, this is the formula, right? Formula. And then right here is 2 pi. So this is going to be my substitution step. I substitute in, and then I multiply. 2 times 10. And that gets me my 20 meters. So there's your extra credit for watching the video. Nice job. Way to get some free points. Right here. Now we're going to go on to the next one. The length of AB. Remember how we talked about the arc length? So the important part of this is that we notice that this is a central angle. And when a central angle is there, we know that our arc, in other words, AB with the arc above it, is the same value. So arc AB and the measure of the central angle, AOB, are the same value. So now I take this and I plug it in. Let's see here, I don't need to do that. I plug it in, get 90 over 36. The zeros reduce, 9 over 36 reduces to be 1/4. So I know that my ratio between the arc, the measure of the arc, and the full circle in degree form is 1/4. Now the radius is 6 meters, so my circumference formula is 2 pi r. I plug in my r, and I solve and get 12 pi meters. Now I can plug in my circumference, 2 pi r, right here, and the measure of AB over 360 is right here, it's 1/4. So I'm going to take both those numbers and combine them into one formula. Okay? This is my 2 pi r. It goes right here. Here's my arc AB over 360. I'm just substituting him in. So 1/4 gets substituted in for this, and 12 pi gets substituted in here. Now 1/4 of 12 is just a 3. So my final answer is going to be 3 pi meters. I did that one on the homework. Now I'm doing it again in the notes, or something similar to it in the homework. Now we look at the same situation. AOB is a central angle, and therefore this is the measure of the arc AB. If I plug it in, I reduce. There's my relationship. Now my radius is 2 pi r. If I plug in 4√2, I have to just multiply 2 and 4 to get 8 pi root 2 meters. I plug that in for the circumference. I use both of those to plug into the formula, and I get 3/8 times 8. Well, that just goes away, and I'm left with 3 pi root 2. So again, this went really fast. The challenge here is going to be able to use this on your homework. Okay, so let's look at one of the homework problems again to make sure we know what we're doing. If I scroll down here, homework assignment 9.7, I believe. Where are we at? 9.7. Okay. So again, central angle. That means that this is the same as arc AB. So I plug it in and I get 180 over 360. Now that's just one part of my equation. And again, remember the equation here, it's asking us to find the length of the arc AB. So we have to put length of AB arc, right, is equal to 2 pi r times the measure of arc AB over 360. That's the equation we're really using here. So that's why we're breaking it apart into parts. Here, this 180 over 360, that represents this piece right here of the equation. The circumference, the 2 pi r, is represented by this part. So obviously my circumference, if it's 2 pi r, is going to be 24 pi meters. But if I didn't want to do this by parts, I could just plug this information in exactly as I see it. So I could do, again, length of AB, it doesn't change, is equal to 2 times pi times 12 times 180 over 360. This is doing it all at once. It may seem a little bit difficult, but if I just reduce this down, 180 over 360, well, that's just 1/2. And then I do 1/2 times 12 times 2. And then there's a pi in there too, right? Pi. So what's 1/2 times 12? Well, it's 6 times pi times 2. 2 times 6 is 12, 12 pi. And now I put in my units of meters, and there's my final answer, is 12 pi. But if I want to do it in pieces, like here, I can reduce this 180 over 360 to be 1/2, and I can just plug it straight into my equation for each piece. So I do length of AB is equal to 1/2 times 24 pi meters. Well, the 1/2 times 24, that gives me 12 pi meters. So I got the same answer either way. I prefer to do it in parts because that's a lot of area to make mistakes in, okay? But if you want to do it all at once, that's entirely up to you. But for me, doing it in parts is much easier. So finish up these next 3 problems on your own. Remember, reduce your fraction, multiply them, and you're done. And then when you're done, get back to the notes, because here we go. So example 9.52. In this example, we're going to find, I'll do it with you in the notes a little bit, so we're on the same page. All right, 9.52 right here. There's a picture that you won't see in the video if you don't have your notes in front of you. So the picture right here is very important because this is where we get this measure of 24 degrees. It comes from our picture. It's the central angle, and since it's a central angle, the arc is also the same length. And then our radius is 1.2, and that's where that comes from right here. I want you to see the picture before we start the notes. All right, so now that's central angle. That means that the arc is the same as the central angle. Here's our circumference formula. We're going to substitute in our radius in there to find out that our circumference is 0.4 pi meters. Now we're going to use our arc length formula and substitute in our value here. Okay, so here's my circumference, 2.4 pi meters. Here's my arc length, here's 24. And then we're going to start reducing down the fraction. Okay. So at the first point, I want to simplify 24 over 360. I can reduce that down to be 2 over 30. 2.4 over 1. Now that decimal really bothers me. So I'm going to go ahead and multiply the top and the bottom by 10. So I get 24 over 1 and 2 over 300. I could have done 24 over 10 if I'd wanted to, but this way helps me reduce the fraction further. So now I can simplify all this, is just simplify my fraction. 1 over 300 becomes 1 over 150. And then the 1's cancel, so I'm left with 24 over 150. And that reduces to be 8 over 50. I can reduce further to get 4 over 25. And my final answer is 4 pi over 25 meters. And that, on this circle, let's see here. If I had a circle, then however big this arc is they created, this length right here is 4 pi. And 4 pi is about 24. So that means that it's about 1 meter long. If I walked all the way around the circle, I'd walk about a meter. Give or take. So let's go ahead and work on problem 14 through 16. 17 through 19 are extra credit. I'll show you how to do one of those on the video here. We'll see how this goes. Okay, so 14 through 16. Here's my central angle of 30. That means my arc length is also 30 degrees. Here's my diameter of 16, therefore my radius is just 8. So here's 8, here's 30. Most of the way done already. Now my length, I'm going to plug it straight in. I say 2 times pi times r times 30 over 360. Now technically this is the correct answer. Problem is that I haven't substituted my r yet. Oops. Okay, so if I substitute in my r for 8 right here, and it looks like I don't have any units, so I'm going to call it 8u, because we don't know what units are yet. I didn't say feet or anything. Oh, units are in meters. Read the instructions. So my radius is 8 meters, and therefore I put an M right here, and I put 8 meters. Okay, so I multiply the 2 and the 8, and I get 16. So I have 16 pi meters. I can reduce down the zeros at the very least, and the 3 and the 36 can become 1 over 12, I believe. Yeah, 1 over 12. And then I multiply the 16 and the 1, and I end up with 16 pi over 12 meters. The 16 over 12 can reduce to be 4 over 3, so I have 4 pi over 3 meters. There's my final answer. So most of this is just the ability to reduce fractions. If you can reduce fractions, then you're golden. If you cannot reduce fractions very well, then let's talk about how we're going to do this one differently. We're going to do them a piece at a time. My radius is 8, so my circumference is 16 meters, 16 pi meters. My length is 30 over 360, and I end up with 3 over 36, which gives me 1 over 12. Times that by 16 gives me 16 over 12 pi meters. Reduce this down to be 4 over 3 pi meters. So that's twice. You've seen me do it 2 different ways. So either one of those 2 directions will work. Entirely up to you how you do it. Again, 17 through 19 are extra credit. We're looking for the perimeter of these shapes. Obviously, it's at least 15 because you have 5 plus 5 plus 5. All I need is find out how big these arcs are and then add them up. You use circles and arc length to figure it out. I believe each one of these would be 120 degrees, if that helps. That's your little hint there for 120s. Over here's these arc lengths here are 90 degrees, and this one over here has a diameter of 7, and it's a semicircle. So your angled distance would be 180. So that's 9.7 up to that point. And then Pac-Man, if Pac-Man eats, all right, so Pac-Man's eating this pizza. The circumference of the pizza is 2 pi r. The radius is 6 inches. The whole length of the crust is 12 pi inches. That's how long the crust is. Now, if he eats a piece of pizza that's 60 degrees in size, then I want to know how long is just his crust. So I would use the central angle is 60, so the measure of the arc is 60. So I use that arc and put it over 360, and then I multiply it by the circumference. That's 1/6 of the pizza. I don't know, 1/6 of the full pizza gets me 2 pi inches. So the length of the arc is 2 pi inches. It's just an arc length using real life problems. And so now we're looking at the difference between an arc and the length of an arc. So the measure of an arc is it's in unit, it's in degrees. The length of an arc, we use that measure to find out how long it is in inches. Okay, so that's the first part of 9.7. We'll cover this concept of radians another time. You should be up to that point. So